Real honor to be up here talking in front of all of you. As an engineer, as Matt kind of talked about, and many of you can probably relate, it's pretty easy to get lost in the weeds, kind of down in the nitty-gritty of the details, just going through the day-to-day. So for the next 20 minutes or so, I want to zoom out and talk about the history of flight. Since the dawn of powered flight, military aircraft have been marked by a series of fundamental technological transformations. Each defines how we think of an aircraft, what it's capable of, and how we will employ it in combat. In the 1950s, we had piston-driven aircraft, and that gave way to jet-powered fighters. We were able to push our pilots much further, much faster, much higher than ever before. And then in the 1980s, we had the integration of stealth technology. This transformed our ability to go deep behind enemy lines, all while being undetected. We find ourselves in the very early days of the next step change in aviation, the integration of autonomy into fighter aircraft. My name is Jason Levin, and as Matt said, I oversee our Air Dominance and Strike Division at Anduril Industries. This past Halloween, we completed some of the very first steps in that new era of aviation. Our YFQ-44 Fury completed the first autonomous first flight of a fighter aircraft in the history of aviation. With the single push of a button, Fury took off, flew its mission, and came back and landed all on its own. This is a short story of how we got there. Now, since the times of Chuck Yeager, there have been rumors and premonitions of someday aircraft burning holes in the sky without humans controlling them. Some of the proposed fighters of tomorrow, Chuck Yeager said in 1953, will be able to find and destroy a target and even return to their home stations and land by themselves. But the path from Yeager's prophecy to reality was very far from inevitable. While technologists, even as far back as Tesla, had talked about unmanned combat aerial vehicles, the first to really gain some traction was the Firebee. Many people in here probably know the Firebee started its life as a target drone, then some smart people got together, added some surveillance equipment, and made it combat ready. The Firebee actually completed thousands of successful combat missions during the Vietnam War. But it wasn't really until the global war on terror that unmanned military aircraft entered the public consciousness. They played a major role in conflicts in the Middle East because they gave us that persistent ISR and precision strike capabilities with great effect. The advances in remotely piloted aircraft, they laid the groundwork for the next step change that was yet to come. They separated the pilots from the aircraft. That foundationally changed combat. We were able to remove humans from harm's way. The Predator, Reaper, Global Hawk, many more provided us those persistent eyes and precision delivery of effects globally around the world without a human ever being in harm's way. But still, these remotely piloted vehicles were just that. They're remotely piloted. While these aircraft did not have cockpits, they were far from unmanned. Each requires 1, 2, 3 operators just to operate them, not to even talk of the maintainers and support crew. The manning requirement for unmanned systems actually places an upper bound on the capacity, the scale, and the complexity of missions that we could execute. We did a fantastic thing removing humans from harm's way, but we were unable to achieve mass with these unmanned systems. In the early 2000s and 2010s, this was enough. The nature of conflict meant that we had total control of the skies. We didn't need mass to dominate. A few highly capable systems were enough to perform the mission. We didn't need fighter-like performance. Altitude alone was our safe haven. But today, as many people know, conflict has changed. We're moving from an environment of a permissive counterterrorism to one that is highly contested, high-risk environment with near-peer adversaries. The capabilities that we used to build and field around the world are insufficient for today's threats. While we were distracted with the counterterrorism fight, our adversaries were working on technologies and capabilities specifically designed to outmatch us. And those technologies, as everyone here works on, they're evolving faster than ever. Evolution is measured not in years, but in weeks and days. But it's more than just the technologies themselves. Increasingly, it's about capacity and mass. We simply do not have enough. The aircraft inventory in the US Air Force is the oldest, smallest, and least ready in history. According to Air Force assessments, China will have superiority of air fighters in the Western Pacific on the order of 12-1 by the year 2027. Our lack of capacity, our sheer lack of tools, platforms, weapons, has eroded our ability to credibly deter conflict. As you all know, manned fighters and bombers are incredible technical miracles, but their complexity means that we can't build and field them at the scale needed. To achieve the scale we need at the speed necessary to meet the threat, we need a new way to regain combat mass and air power. We need a fundamental step change in how we do this to bring that capacity to the fight on a timeline that's relevant. When Anduril was founded in 2017, we had a singular goal: to transform the US and allied militaries with advanced technologies. Anduril was founded because despite all the great technological progress happening around us, we felt the defense sector was stuck in the past. The biggest defense contractors were not working on advanced technology. They were prioritizing shareholder dividends over advanced technology, putting bureaucracy over breakthroughs. The world's best engineers, technologists, software developers were not working in the national security space. They were over in Silicon Valley working on Snapchat filters, Facebook ads. So Anduril was founded to rediscover America's competitive edge. We're going to leverage America's best and brightest engineers, bring them together and pair them up with veterans, national security experts, people that understand the warfighter's problem day in and day out. And then together, that combination, our founders hope, would allow us to bring advanced technology to the national security space. Our first pitch deck to investors actually include autonomous fighter jets as one of the products we were going to build. To say that was a moonshot was an understatement. For the last several decades, every major military aircraft has been built by one of a handful of traditional primes. And this makes complete sense. These companies have decades worth of aircraft manufacturing experience, connections with the right program offices. They have the infrastructure, facilities to build these airplanes. The idea that Anduril could step in and build large, autonomous aircraft was ambitious at best, and probably a lot of people would say even laughable. Now, we faced our fair share of challenges. In fact, our first time to try to build autonomous fighters didn't go so well. In 2020, the Air Force announced a program called Skyborg. They were going to build uncrewed fighters to team with crewed fighter aircraft. And a 3-year-old company such as Anduril, we weren't going to build the airplane, but building the autonomy software, that was probably plausible. So we responded to the RFP to build the autonomy software for Skyborg. It felt like a natural fit. Anduril, although we build hardware products, at our core, we're a software company, and more than that, we're really an autonomy company. Our autonomy stack powers hundreds of sensor towers at the southern border, a variety of small drones, air defense systems. So surely, we could automate large autonomous aircraft. Long story short, the Air Force passed on our proposal for Skyborg, and that could have been the end of it. But it wasn't. We kept working, honing our software, making it ready for prime time. We had no classified infrastructure, so we used to have to fly to Air Force bases to send secure messages or show the Air Force what we were working on. With no classified infrastructure, we wrote project proposals by hand, pen and paper, sometimes typewriters, or we would fly to a base, some secure room, some poor airman had to babysit these crazy people from a 3-year-old company named after a fictional sword. It was wild. But this laid the foundation for everything that was to come. Skyborg was also an early indicator of where the Air Force was heading. They realized to regain air dominance, they needed large amounts of autonomous systems. Then, the real starting gun came when the Air Force announced the Collaborative Combat Aircraft, or CCA program. This built on the foundation of Skyborg. The Air Force was going to develop and field many of these uncrewed fighters to team with crewed fighter aircraft. Crucially, however, the Air Force planned to do this at scale. And the service laid out the idea of building thousands of CCAs in the year to come. This was it. This was our shot to redefine air power. Now, we'd made progress on the software since Skyborg, but we still didn't have an airplane. And the Air Force was obviously going to want both. So we did what seemed like a practical thing. We teamed with several prime contractors that build airplanes. The thinking was pretty straightforward. They would build an airplane, we would bring the software. Without going into the details, that also didn't work out. But we kept at it. We met this small 80-some person company called Blue Force Technologies. They kind of had the outline of an airplane, but they didn't have the software or the scale to take it to the next level. But it was a natural fit. We teamed with Blue Force, then we acquired them, and then we finally had the concept of an airplane. But we were still in 5th place. We were dead last out of 5 companies competing for CCA. We didn't even have an airplane. We just had the idea of an airplane. But we climbed, a small team, working around the clock, fueled equally by the conviction that what we were building was required for the US to project air power, and a chip on our shoulder to show that a new company could compete with traditional primes. We clawed our way from 5th to 4th to 3rd, working to understand our customers' problems and attacking them one by one. As the lead engineer at Anduril likes to say, we answered the bell over and over again. Then we got our shot. On April 24th, 2024, the Air Force announced that they had selected Anduril and General Atomics to build prototype CCAs. There was huge elation, right? We were selected. We were going to do this. But that was quickly replaced by the weight of the problem ahead of us. We now had to actually design, build, fly these aircraft in a matter of months. Now, everyone here knows designing and building an airplane, it's extremely challenging. I could talk about the trials and tribulations of that. But I started the day talking about autonomy, the software. That's what really unlocks the key step change in capability. So I'm going to focus on that. Now, we weren't just building any airplane or any fighter. We were going to build the world's first autonomous fighter jet. So we faced a core question. How would we perform first flight? Would it be autonomous or remotely piloted? Now, by this point in Anduril's history, we had made significant progress on our safety-critical software that would eventually fly Fury. The same as a commercial software company will develop a core product and then customize it for different projects, we had built a vehicle management system software at Anduril. This worked on many of our small drones, interceptors, and autonomous submarines. It had been in hundreds, probably thousands of tests across Anduril, and was even flying on a fleet of Fury surrogates. But still, the thought of Fury taking to the air for the first time on this homegrown software with a pilot to take over, that was extremely daunting. This was Anduril's highest profile program. If we screwed this up because of some silly software, it was bad times. Not to mention that, this was the top modernization priority for the US Air Force, something that hundreds of people had spent their blood, sweat, tears building this airplane. So this caused many heated internal debates. In one camp, they said that you needed to fly with a joystick. You would get to first flight faster and have the flexibility. The history of flight testing is riddled with mishaps. So our crewed and RPA pilots argued first flight must be done remotely. You can have contingencies, respond better. This is the reason that unmanned aircraft are flown remotely. Or another camp argued, albeit mostly engineers, said this could all be done in software. And this was an autonomous fighter jet. So it wasn't a question of if, but when it would fly autonomously. They argued that building in all the hooks to fly remotely would delay the program. It would be dead-end work that'd have to be scrapped and go against the ethos of speed to ramp. So many of you might recognize the crossroads we found ourselves at, between the known and the unknown, the comfortable and the unfamiliar. So what did we do? Like any good engineering company, we split the difference. We went fully autonomous with the ability for a pilot to take over with the joystick if something went wrong. We even started designing our own custom Anduril joystick. Had all the buttons and knobs you could ever want. It was going to be pretty sweet. This probably is not surprising, coming from a company founded by the world's most preeminent video game collector. But while we were building the joystick, something felt wrong. Right? We kept questioning ourselves. Aren't we an autonomy company? What are we doing? So we got the conviction, and we went all in on autonomous first flight. We scrapped the joystick, we built in all the hooks into the software for contingencies, and we built all the rigor, and we got after it. Stepping into a new age can be an uncomfortable process. The wreckage from early tests of fighter jets, the challenges of integrating stealth technology, they serve as proof for this. But technology only advances when a few people are willing to take a big swing. There were no textbooks on how to build an autonomous fighter jet, not a lot of historical references we could draw upon, but it came down to something straightforward: listening to what the customer wanted and trusting our team to build it. So when Fury took to the air for the first time on October 31st of last year, it did so with the push of a single button. There was no one waiting in the wings with a joystick to take over if something went wrong. So there we were on the day of first flight, nerves very high, Fury's nose is pointed down the runway, and the operator hits the button. It accelerates down the runway, rotates, and takes off into the sky. Cheers ring out from all the onlookers, but we were far from done. We huddled anxiously around the radio, listening as the chase pilot called out test points the Fury was completing. But then our anxiety was really at its highest when we saw Fury in the distance on final approach. Everyone here probably knows this. Taking off is easy. Landing is something completely different. Someone more eloquent than me wrote some notes that day that I wanted to read. Not an engineer, obviously. The crowd was silent as the airplane descended in the distance. Time slowed, hearts raced. Fury touched down gently on the runway, hitting the center line with robotic precision. A collective exhale spread across the crowd of onlookers. Weeks, months, years of work for that single moment. Blood, sweat, tears, 100-hour weeks, all fueled by a belief in the capability we were building and the willpower to execute on it. Now, I like to think the story of the road to first flight is more than just a microcosm of how we operate at Anduril. I hope it provides some insights into how aerospace technology advances, whether in defense or really otherwise. And the first is identifying the right problem. Yeah, our initial pitch deck had the idea of autonomous fighter jets and other cool projects, but not just because we thought they were cool, but because we thought they were required for the US to have superiority in future conflicts. We thought autonomy was necessary to bring that combat mass and deter our future adversaries. The second is the importance of conviction. Conviction is taking these crazy moonshot swings on a little bit more than hope that you can succeed. Conviction is believing you have the problem, you have the team, and you can solve this. And then the third is the understanding and the appreciation that moving into the unknown is uncomfortable and often unfamiliar. Conquering the unknown requires more than just expertise. It requires the willpower to execute on that expertise day in and day out until you solve the problem. For us, getting to first flight was a huge milestone, but we are so far from over. We like to equate it to the climb from going from underdog to on contract to first flight, a lot like the climb to the Mount Everest base camp. It's super cool, you can take some selfies, but the hardest part is yet to come. Since Halloween, we've continued flying Fury. We have multiple aircraft flying on a regular basis. This next year is just epic for the program. We're going to move the build of Fury into our hyperscale production facility in Columbus, Ohio in a matter of months. Fury is going to perform live weapon shots, perform multi-ship flights, fly alongside crewed teammates, and operate outside test locations. The challenges that lie before us are daunting, but they are equally exciting, and we're going to approach it the same way we've done in the past, by deploying equal amounts of expertise and willpower to write the first pages in the next chapter in the history of aviation. Thank you, and I look forward to your questions.
Well, thank you, Jason. Appreciate you sharing the story of Fury. And we have some, we'd like to take some time now to talk about some questions. And I thought maybe to start things out, we have a large student group, I think on the order of 2,000 students here that are looking to come into aerospace. And they're making decisions on where they should go and what they should do. And we've got marvelous opportunities in commercial space, civil aviation, and the defense sector. I'm wondering if you could share a little bit your calculus when you've made decisions to change. I remember specifically getting a call from you in 2017, and you were telling me, I'm going to go join this company called Anduril. And I was at Sandia National Labs at the time, and I remember thinking, wow, what a cool name, and what a bold move. But you had a successful career going for you, and not so much the specifics of the decision, but how you went about making a decision like that might be able to help folks who are contemplating changing career directions or coming out of school. Any thoughts?
Yeah, at least for me in my career, I've always looked for new challenges and how to progress and how to keep moving forward and look for the new things. So I was very happy at where I was before Anduril, and just the thought of a new company coming around and disrupting the field and doing something new. I knew it was a huge challenge, and I wanted to take that on. And I also knew that it was going to be extremely uncomfortable and just worth pushing myself and others to go do, right? Leaving a large aerospace firm where you have job security, things are going great, to go to a company that maybe has 6, 12 months of runway is a daunting thing, but it's equally exciting at the same time.
Okay, great. Well, we have some questions from our audience. Maybe we can dive into those. In an era where manned aircraft are still prevalent, how do you ensure that autonomous fighters do not attack friendly targets?
Yeah, I think there's a lot of concern on where the autonomy will live. And so we're doing a lot of work to make sure that there's a human on-the-loop aspect to all the autonomy. So the human can make final decisions on which targets to engage, what to do, and things like that. So I think a lot can be built into kind of where we put humans on the loop and the decision-making there. And I think that's one aspect of how we'll be able to step into the new age of autonomous fighters.
Okay. Maybe unpack a little bit more about this human on the loop. That's one of the themes of this session in terms of, autonomous systems in general and having, the command authority being, traced back to some person and responsible. Can you talk a little bit about that?
Yeah, the way that we like to develop a lot of our autonomy is thinking through that there's probably an eventual end state where potentially there are no humans on the loop. And so we want to develop this software to make sure that it can do the full mission fully autonomously, and then just start to put in checks where a human might have a better decision making or have more information where they can make a better decision as they step into it. We do this across systems at Anduril right now. We have a variety of air defense systems that sometimes can operate fully autonomously, where they can detect drones and jam them and intercept them, or sometimes they operate with humans on the loop that want to make the decisions of each to do. And it'll just determine by the rules of engagement and kind of the policy as we move forward.
Okay. So another question is, how does Anduril plan to address the maintenance and sustainment of a large number of CCAs fielded across the globe?
Yeah. It's also a concern, as I kind of talked about. It's not just humans operating the aircraft, but it's the logistics and it's the maintenance. So we've designed Fury to basically require no maintenance. So when you can deploy a Fury, you can deploy it with 18-year-olds that all they have to know how to do is load a weapon and refuel the jet. So all the other health checks are done autonomously. It knows what service needs to be done. The service intervals are very long in between. So we really thought about reducing the footprint. And one of the ways that we like to think about this is similar to a business jet when it lands at an FBO, right, a fixed bait operations kind of airport out there. It doesn't bring a bunch of equipment with it. It lands, it gets fuel by some 18-year-old that lives locally, and then it can take back off. That's how we've thought about designing Fury. To be able to be deployed for agile combat employment in large numbers of these out in the islands in the Western Pacific, it needs to just be able to land, refuel, rearm, and get back in the air with no maintenance.
Excellent, excellent. So here's a question, and this one's going to have some subtleties to it. Was the first test flight actually autonomous, or was the flight program before, like following a path?
I guess this is where it comes down to your definitions of autonomy. It was autonomous in the sense that there was no human interacting with it other than telling it to take off and come back and land. But yeah, it was a pre-programmed, following a specified path, but then maneuvering based on contingencies or air traffic.
Right, right. So in an era where manned aircraft are still prevalent, how do you ensure autonomous fighters do not, well, let's see, we hit that one. So how about, what advice do you have for aerospace startups to be successful as they compete against large established companies?
Yeah, I think to be successful, I think I kind of talked about this a little bit in my talk here. I think there's a conviction. So I think the importance of identifying the right problem. So when we think about things at Anduril, we think about what is a large problem that we want to go after? What is something where a customer wants to bring us in and solve this problem? And then we talk a lot at Anduril about conviction. So then we have to have a strong belief that that is the problem and that is what we want to solve. And then you're like almost seeing the future. If we build that and if we solve this problem, we will be successful. And then it's just a grind. Then it's just hiring the best people, making them excited to work on the product, and then just grinding it out and just delivering that product.
Okay, so now we're going to touch on aircraft design. How do you do engineering differently at Anduril, different than, say, the larger aerospace primes? Is fidelity, multidisciplinarity, schedule, organization, what's distinctive about Anduril?
Yeah, so I think at Anduril, since we're a new company, because we don't have ingrained process or kind of tool chains, that's both a blessing and a curse. So we don't have a historical reference to draw upon for how we will do design, the design rigor, the different tools to use, so we have to kind of make it up on the fly. But then since we've hired some of the best and brightest, they bring all that baggage, both good and bad, of where they came from, and then they can kind of figure out the right tool sets and right way to do the design. The other thing that we've implemented that I think has worked quite well is on these big projects, you have to approach them through probably like a very big, IMS, integrated master schedule, right? Thousands of lines, all interchanged, very waterfall schedule. You probably need to do that. It's a very complex hardware project. But then what we've done is also broken that down into basically monthly sprints, so we can kind of match like the waterfall with the agile methodology. And the reason we've done this is if you have a very big schedule, it's increasingly hard to determine, like, are you actually making progress? Where are you in the design? But as we have monthly demonstrable events where you can see a landing gear showed up or it didn't. It's a very Boolean pass-fail. So I think having gate criteria where we can see if we're making progress, similar to a software company would have agile sprints and see where the progress is being made, that's how we've kind of approached hardware development as well.
Okay. So using that agile methodology, I know that we've, on our other products where we've, that haven't been at the scale, let's just say a Fury, we move very fast and we're updating software to the last minute. Can you talk a bit about the certification and airworthiness and the impacts of that, and maybe an appeal to any things that need to be improved there?
Yeah, yes. So Fury is our first program that has the level of rigor, has to go through Air Force, airworthiness, and also we really can't crash it. So it's just a completely different level of testing and verification that we've done on the software, vice something like Roadrunner, Ghost, Anvil, one of our other flying products. I would say the US Air Force leveraging a lot of the airworthiness standards on us has potentially slowed us down, but at the same time, I think it's increased that level of rigor to make sure we've been successful, and to date, we've had a bunch of successful flights. So I think that's just a kind of a hallmark to the process we created is kind of working. I will also say the US Air Force for this program really has the urgency to move. They want to feel this. There's the speed to ramp aspect that they talk about a lot. And so they're willing to kind of break down walls where they don't make sense. So I think the right approach is figuring out the pieces of the rigor and the airworthiness process that we need, that are the good pieces, implementing those, and then probably cutting out the rest of it.
Yeah, you think about, and you alluded to this in your talk, the history of aerospace and all those hard-fought lessons learned over the past century now. And those are baked into a lot of these airworthiness certification processes. So you can't just dismiss that. But like you say, it was nice to be able to, if something didn't make sense, to challenge that and move, see if we could break through some of those barriers.
Yeah, I think we have a pretty unique opportunity on the CCA program in terms of the U.S. Air Force and the program office there. They really do want to move quickly, so they're willing to adapt. I mean, there's other program offices that are a little bit more challenging, so I think we're pretty fortunate right now.
I wonder if you could share, too, about the way we've interacted with a customer on Fury and how that's helped things.
Yeah, so the U.S. Air Force, the Agile Development Office, the ADO that runs this program for CCA, they talk about knowledge parity or full transparency. So the Air Force is actually completely embedded in our tool chains. So like we like to say, the Air Force, like they basically walk amongst us in our halls. They have Anduril badges, Anduril laptops. They come and eat at Anduril cafes. They're just like there. They're in the work. They are seeing the sausage get made. And so that has pros and cons, as one can imagine. The big benefit is they are seeing decisions being made every day. We don't have to do a bunch of work and a bunch of design and then have this big design review and then have changes that go back. We can make decisions day by day on what needs to change as we find things in the design. And then the flip side is just that same thing, that sometimes they'll freak out when they see something that's not going right? Engineers are going to make mistakes, things look weird, data's not always right, and so they'll kind of over-rotate a bit there. But I think just working with them closely over the last several years has got them pretty accustomed to when to react and when not to react.
Yeah, it certainly has built up trust and understanding. I mean, they have a deeper understanding of our product and the decisions we've made. It's been great. Can you elaborate on how you're planning to meet affordability and fast production goals on the program?
Yeah, so kind of the main aspects of the program are schedule, cost, performance. That's been mandated by the US Air Force. And so schedule is about getting this thing in the field, getting it out into the Pacific as fast as possible. So we're focused on that. But then it's cost, because we do talk about affordable mass, so it has to be affordable. And so if we've learned anything at Anduril, it's that you can't develop a product and then try to make it cheaper in the end. It just doesn't work. So you need to think about costs from the very upfront and production from the upfront. It's really hard to also, we've learned the hard way, it's hard to take something that you've made and go into high rate production if you didn't think about it from the beginning. So the way we've approached Fury is kind of the same way as you might approach kind of building a car. We know we're going to build thousands of these, so we've made design decisions in terms of what can we get off the shelf, what can we make out of just billet aluminum, what can we use just like regular processes to make. So even the composites on Fury, it's nothing proprietary, it's nothing exquisite, any composite shop can make it. We like to say our landing gear is made out of billet aluminum. Any machine shop around the world can make the landing gear for Fury. So this is pretty unique aspects, and just picking them off one by one means we can have a wider supply base, which will reduce cost, and then allow us to ramp, if necessary, into the thousands of airplanes.
So speaking of being able to manufacture around the world, one of the questions from our audience is, will this product be available in NATO countries? Could you talk about maybe the...
Yeah, there's a lot of interest in kind of partnering with our international allies right now. And so we have designed Fury from the get-go to have as minimal or no ITAR components in it as possible to make it EAR compliant for export. And so we like to think about it as the baseline Fury, and then there's the YFQ-44, which is the US Air Force variant that is specifically set up for the air dominance mission. So then we have other configurations of Fury that might be more usable in the European theater, more in like an air-to-ground mission or an electronic warfare mission. And so we have a lot of interest from allies in Europe and in the Pacific of basically acquiring Fury for other configurations. And we're partnered very closely with the US Air Force on this while working through export compliance and working with offices within the Air Force. So it's kind of one team within Anduril and the Air Force going after, helping our partners and allies.
Okay, great. Pivoting back to the discussion on autonomy, where the main theme of your talk, can you comment on the ethical questions on autonomous fighters, especially around lethal engagements?
Yeah, I think we like to think about it, Anduril, that that's not really our place to make the decisions, right? That's kind of elected officials and policymakers. So what we're going to do is we're going to code the software to the policy of the day and make sure it is safe and make sure it meets everything that's the standards of the day. And then as kind of ethics change, policies change, we will adapt with that. But that's not really Anduril's decision to kind of make the call on whether or not it'll be autonomous lethal engagements.
Yeah, and you think about a lot of our tactical missile systems since the Vietnam War. The minute you pickle that thing, it's autonomously flying to the target. And so the fact that there's more capability like that, but that's smarter, as one of our founders say, that maybe that can recognize the difference between a school bus and a truck or a military target should be a good thing, right?
Right.
So what challenges, continuing this theme on autonomy, what challenges have you come across deploying a generalized autonomy stack to diverse platforms?
There are a lot of challenges in that, and that's where we like to think about it a similar approach to commercial software companies. We'll have kind of a baseline autonomy infrastructure, baseline autonomy architecture, and then we can customize it for the different applications. So one could imagine that the path planning that is done for our autonomous submarines is going to be quite different than done for our autonomous fighter jets. But you would still probably realize that there's going to need to be a path planning kind of microservice, and maybe some of the foundational building blocks of that microservice would be common, but maybe the specific kind of development would be a little bit different. So we've just had to kind of piece off where is their commonality, build that into the core infrastructure, maybe build the building blocks on top of that for the different kind of microservices, and then customize only when we're needed to. Because as soon as it goes customized, it's just not going to be usable or transferable to another product.
Great. Okay, so we have an interesting personal question that's bubbled up to the top here. What are your top 3 mistakes that you're willing to share, and what have you learned from them?
Top 3 mistakes. There's a lot of Anduril people in the crowd, and I don't want to call out too many of them. So,
maybe just pick one and then come back to it as you think of any.
Yeah. I would say some of the, trying to think of mistakes that we can kind of share more publicly. I would say one of the mistakes that we made during the early stages of Fury testing was probably just like the not having great rigor around kind of our test site. So we were building up, right? We had test sites where we've flown Roadrunners, interceptors, submarines, boats, all sort of things. But having a test site where we can fly fighter jets is a different story. So we're building up that test site, building in the rigor of how we do things, even just like where parts would go. And so when we had that test site and we first stood it up, we would have a couple of our Fury aircraft there. And just when the parts would get shipped from another department to kind of put on the jet, they would just like randomly get lost at our test site. And so basically Fury would be down for a couple days as people are searching randomly for like a wiring harness that was probably like at somebody's desk at the test site. So I think just like there's been silly mistakes where just we didn't have that infrastructure, and it just brings the program to a halt. And I think there's probably countless other examples that I'm not going to talk about publicly on the engineering design that happened the same way, where I like to say at Anduril there's a lot of 2 steps forward, 1 step back. And it's like we got an autonomous fighter jet to the airport, but like we didn't get the cable to turn it on. And so like there's a lot of little things like that.
Great. Well, maybe along those themes, I know there's been a healthy discussion internally and externally about failing fast, failing forward, and it's got to be different on the different products that you're developing. Could you comment on just your take on that?
Yeah, I think a lot of people talk about failing fast, and we even have to talk about this internally to Anduril a lot. I think sometimes people think that means you just YOLO something, but like every time we go into a test, we know there's an expected outcome, and we take on some risk. So when we went into a test of, let's say, Roadrunner, right, or a VTOL surface-to-air interceptor, we had several other Roadrunners waiting to fly, so we could accept more risk in that first flight and know that we were going to transition to forward flight. If we didn't get the vehicle back, we test the next one the next day. But we didn't go in not knowing what would happen. There was always going to be the unknown unknowns, but the prediction was it was going to fly and be successful, right? And so we just take that same methodology to something like Fury, and now we have to be predicting that it's going to work and be like really, really sure it's going to work. So like you kind of talked about the rigor that we went in for that first flight. So I mean, we were willing to accept risk. The Air Force is willing to accept risk. The amount of testing and rigor that went into first flight of Fury, I'm sure, is nowhere near the same as a manned aircraft. But that was risk we were willing to take.
Yeah, I mean, tests have outcomes, and you learn either way, but you need to fail safe, and it also, like you say with Fury, it needs to be sort of calibrated to the risk posture of the program, I think. And yeah, you see, your team seems to do that really well. So
yeah, it's something you mentioned there about testing. The U.S. Air Force on the CCA program, they talk a lot about we're testing to learn things, which is very different. Basically, past programs, you're testing to make sure the thing works exactly right. That's not what we're doing on CCA. We're testing to learn. So we need to make sure each test we do, we actually are going to learn something from it.
So modern fighter pilots have started to adopt more of a battle management role. Do you see the level of decision-making ever being integrated into an aircraft level autonomy?
Yeah, I think that's possible. I think the kind of first foray that they'll do this will be more of like the air battle manager, where kind of right now, your battle manager will kind of task, right, a certain squadron to go perform a mission. I think that's how they'll think about interacting with things like CCA, is say, this 4-ship, go over here, sanitize this lane, that is your task, and that's how they'll begin interacting with it. I'm not sure. I'm sure there'll be some day that'll eventually get to the point where somebody will just say, hey, you 1,000 Furies, go figure it out, and they do a good job. But I think initially it'll just start with treating them like kind of like one squadron.
Okay. So this question is, Anduril's the new kid on the block. Without platitudes or jargon, how can the Department of War trust you equal to another prime? So I think it gets at an important question like trust, and how do we build trust with our customers?
Yeah, we like to say a lot of times, and the customers that have been crazy enough to take a kind of a swing with us is like, just like let us have an opportunity, let us show that it works, and just like keep checking our homework along the way. So we do really well with the U.S. Air Force on CCA because they're in our stuff, they're seeing what we're doing, and we're just proving to them every day that we are making progress and we are making capabilities. The same goes for a lot of our low-cost missile systems. The customers with us, they said, can you really build a low-cost cruise missile? Can you really build thousands of it? We said, we're going to prove it to you. And so each step along the way, we just prove it, and we say at any time, if we're not meeting the expectations, you can fire us.
Okay. So the first word in CCA, collaborative, the question here is, how are these systems really collaborative? What does the communication between operators, crewed aircraft, and CCA look like?
Yeah, so the CCAs will have a variety of line of sight and beyond line of sight data links to be controlled from multiple places. And one thing the Air Force has done is they have separated the aircraft from the mission autonomy level. So we like to think about it as flight autonomy is all the autonomy I kind of talked about today to make the airplane act like an airplane without a human pilot. And then mission autonomy is the next level to kind of take all the sensors, perform the mission, and engage the threats. And so they've identified and defined an autonomy government reference architecture, this AGRA, that sits in the middle. And that's kind of explicitly defining kind of that collaborative, what the links are, what are the message sets, what's the ICD, both like logical and software defined that we're going to use between the two. So I think it's becoming fairly standardized so we can actually adapt a lot of that autonomy in the future across these data links and even across the jet itself.
Excellent. And this next question kind of relates to that is, how is our aircraft autonomy software, how agnostic is it? Could the same or similar systems be swapped between different types of configurations? Could we use different autonomies?
Yeah, and I think we're trying to prove this today, right? Working with several different autonomies on the jet and even just having our autonomy fly other aircraft as well. I think it'll be obviously customized to whatever the specific configuration of the jet, right? Its capabilities, its flight profile, its mission system sensors it has, and what it's included and how you want to operate it. But I think there's a fundamental layer that can be transferable pretty easily.
Okay. Pivoting now to maintenance-related questions. So you say it requires no maintenance. How many missions do you expect one to be able to fly? What trade-offs between durability and the cost of hardware? Can you comment on that?
Yeah, we're designing these aircraft for hundreds, thousands of hours in between overhauls, and so there's different schools of thought even within the Air Force of how they'll operate these aircraft. One school of thought, there's no pilots, so you don't need currency, so they're really going to be flown a lot, or you're going to have a couple assets that are flown with test wings, maybe somewhere in Nevada, and then the rest are basically just going to sit somewhere waiting ready for combat. And so it kind of depends on how you want to think about that. But either way, we're designing such that they can do hundreds, thousands of hours, which is hundreds of sorties in between needing any sort of overhaul or maintenance.
Okay. This one's kind of fun. How many hours did you work on average leading up to October 31st? No comment.
Yeah, a lot. Yeah. A lot of the team, I like to think, maybe my team will tell me otherwise, I like to think a lot of the team is actually passionate about this work. And so hopefully they don't feel like the work actually feels like work, like they're actually getting to build an autonomous fighter jet. Like there's not that many cooler things in life. So although it's work, it's pretty exciting to at least be working on it.
Yeah, the lights are on at different hours, so weren't they? Yeah. As a fairly new company attacking new technologies, where do you find the people that work this program? What range of experience was there?
Yeah, so this is where it's kind of fascinating at Anduril, and it's kind of a melting pot. So we have a lot of people from traditional primes, right? They come from people in this room, from the companies that are in here in aerospace. But then we have a lot of people that come from Silicon Valley. They come from Google, Meta, OpenAI. And it's like pretty interesting to actually pair them up together, or people from Tesla, SpaceX, automotive, and you kind of pair them up because to build a fighter, we probably need people that have worked on fighters. But we don't want everyone that's worked on fighter, then we're just going to do the same thing as it always has been done. So we need some people maybe thrown in the mix from the Google or Meta that don't know how to build a fighter, but they know how to deploy software really, really fast and kind of throw them together and pair them up. I will say one thing that I think the bar of folks at Anduril is extremely high. We were talking about this recently, and all the people we get are just like the best and brightest, just complete rock stars that want to get it done. And I think it draws just the problems we work on and the fact that people are given a lot of autonomy and authority to make decisions. I mean, you kind of talked about the team that's writing a lot of this software. This is some of the first software they've written, and they're writing software that's going to fly on a fighter jet. So it's pretty cool.
Yeah, it's pretty exciting. Why don't we wrap things up with this? As Anduril is getting larger and winning contracts, what deliberate steps are you taking to stay adaptable and agile? So we've become a big company very quick.
Yes, we worry about this a lot. This gets brought up internally, gets brought up externally from our customers, is how are you just not going to turn into another prime and slow down? And so we take very deliberate steps internally for both making sure that we put kind of culture carriers, culture leaders that have been at Anduril in projects and place them in there. We don't want to start a new project, hire everyone maybe from the same company, they work this project, and then they just have kind of group think. So we take other Anduril people that maybe don't have expertise in that domain and just like throw them in the mix, and they're kind of the culture carriers to keep it going. The other thing we do, as I kind of talked about, is we have these monthly demonstrable things on every program. And so we can quickly see if a program is kind of beginning to slow down or get the wrong vibe. Because if every month they're coming and showing me something of what they're working on, I can quickly identify, like, this does not feel right. This is not how Anduril is supposed to operate. And then we can go kind of fix it. We spend a lot of time worrying about that.
Okay. Well, any final comments that you'd like to make or advice for our aerospace community here?
No, this has been great. I want to thank you all for listening this early in the morning. So really appreciate it. And thanks again to AIAA for having me. This is great.
Yeah, well, help me thank Jason.